It is May 1993. A 19-year-old Navajo athlete, healthy, no prior conditions, no warning signs, collapses while running to his fiance's funeral. His fiancée had died 5 days earlier. Same symptoms, same trajectory, both dead within hours of respiratory failure. Their lungs were filling with fluid faster than anything in the medical literature could account for. Physicians had never seen anything like it. Within weeks, the CDC launched emergency field investigations across 3 states. Doctors were watching patients drown, not in water, but in their own lung fluid, while every existing diagnostic test came back negative. That investigation ripped open a secret. The virus had been circulating for decades, silently, invisibly, in the lungs of mice in barns and cabins and storage rooms across the American Southwest, and nobody had thought to look. It doesn't need a mosquito. It doesn't need a bite. It just needs you to sweep the dust in a cabin you haven't opened since last summer. It's called Hantavirus. In North America, it kills 40% of everyone it infects. Not 40% of the elderly or the immunocompromised, 40% of everyone. And here is why you need to stop scrolling. In 1993, this silent killer emerged in the dust of the American Southwest. Today, in May 2026, a mutated strain is ripping through a cruise ship in the Atlantic. The question isn't what is hantavirus. The question is why, after 30 years of knowing exactly how it kills, are we still utterly defenseless?
Here is how Sin Nombre virus, the primary North American strain, kills you. It does not attack your organs the way most pathogens do. Instead, it targets the microscopic cells lining the blood vessels threading through your lungs, the barrier your body relies on to keep blood and air separated. Your immune system launches a targeted cellular attack. A specialized class of killer cells floods the infected lung tissue. That immune surge causes the capillary walls to leak so severely that plasma floods the lung tissue. The patient effectively drowns in their own fluid while conscious and breathing. What makes this devastatingly difficult to catch in time? The early phase, called the prodrome. At this stage, no doctor examining you would separate it from a bad flu. Fever, deep muscle aches, fatigue. For 3 to 5 days, it looks like a bad flu. Then the cardiopulmonary phase begins. Within 24 to 48 hours of that transition, 38% of patients are dead. The intervention window is measured in hours. You aren't scheduling a doctor's appointment. You are racing to an ICU before your lungs fill completely. Now expand the map. Different strains of this virus have been confirmed on every inhabited continent. The rodent species change, but the mechanism is identical. Dry droppings, disturbed dust, and lungs that cannot defend themselves. There is no populated region of Earth where something like this is not already present. The geography of risk is wherever rodents and humans share a wall. In 1993 and in 2026, the deaths have one thing in common: a moment of ordinary domestic contact. A broom, a dustpan, a door opened after months. The CDC identified 5 environments where you are most likely to inhale this virus: a closed cabin after winter, a barn with active rodent presence, an attic or crawl space you haven't entered in months, a storage space being cleared or renovated, your own home, if anything has been living inside the walls while you were not looking. The CDC investigation revealed something striking. Sin Nombre virus was not new. When researchers went back and tested preserved tissue samples stored in hospital archives, they found hantavirus antibodies in blood from patients who had died years, even decades earlier, recorded in the files as cause unknown. The 1993 outbreak was not an emergence. It was a visibility event. An El Niño weather pattern had produced unusually high rainfall across the Southwest. That rainfall triggered a pinyon nut and grasshopper population boom. That boom caused the deer mouse population to increase tenfold in under a year. 10 times the mice, 10 times the exposure surface. The virus had been there the entire time. The conditions simply aligned to make it impossible to ignore. Science has now cataloged over 50 distinct hantavirus strains globally, many in rodent populations whose territory is actively expanding. Several have never been documented in a human case, not because they cannot infect humans, but because the villages where people are dying of these viruses do not have a laboratory within 200 kilometers. No PCR machine, no refrigerated sample transport. A person gets sick, the family buries them, and the virus continues. There is one fact that separates hantavirus from being a pandemic-tier pathogen. One biological limitation that makes it terrible but contained. Unlike influenza, unlike COVID, unlike measles or tuberculosis, hantavirus cannot pass from person to person. The chain of transmission ends with the rodent. You can carry it, suffer from it, and die of it, but you cannot give it to anyone. That containment rule is what keeps hantavirus off the most alarming threat lists. Hold that thought.
Unfortunately, there is one strain that does not follow that rule. It is circulating right now. And for 30 years, the scientific community has known about it and said almost nothing in public. The Andes virus, circulating in Argentina and Chile, is the only hantavirus strain ever confirmed to transmit human to human. In 1997, a terrifying outbreak in southern Argentina shattered that assumption. And then the healthcare workers started getting sick. No rodent contact, no droppings, no cabins, just proximity to a dying patient. A 2014 research study confirmed the mechanism through detailed genetic analysis of outbreak clusters. The case fatality rate of Andes virus HPS in some outbreak series exceeds 50%. There is no FDA-approved antiviral treatment for any hantavirus strain as of 2026. Ribavirin, the antiviral evaluated in controlled clinical trials, showed no significant mortality benefit in HPS. Treatment is entirely supportive. In the most severe cases, doctors are forced to use ECMO, a desperate machine that manually pumps blood out of your body just to breathe for it. The scientific community has known for nearly 30 years that one strain of this virus breaks the fundamental rule that makes the others containable. Andes virus continues to circulate today with no vaccine and no treatment.
This is the start of the vaccine question. South Korea and China already have a vaccine, deployed since the 1990s, with documented protection against the kidney-attacking strain that kills tens of thousands there every year. That took political will and commercial interest in those populations. For the people dying of HPS in the Americas, neither exists. Scientists in the US have already demonstrated vaccine candidates that produce measurable immune responses. Phase 1 trial data exists. The science is not the obstacle. But the strain killing people in the Americas only records about 300 to 600 cases a year. That number is too small to make the economics of Phase 3 trials viable for any major pharmaceutical company. And so, the trials do not happen.
The person most likely to die from HPS in 2026 looks almost identical to the person who died in 1993. Working land, far from a teaching hospital, unaware that what they thought was the flu had already crossed the line. The virus is not neglected because it is scientifically difficult. It is neglected because the market for saving its victims has been deemed too small. Before the CDC arrived in 1993, the Navajo Nation's traditional healers had already identified the threat, the unusual mouse population density. They knew what it meant. That knowledge came from generational, observational understanding of the land. Years later, the CDC admitted the truth. Collaboration with traditional Navajo healers is what ultimately cracked the case. The people living closest to the virus understood it first, in different terms, before modern epidemiology gave it a name. That is not a footnote. That is a lesson about whose knowledge counts and when.
Here is what you now know that virtually no one else does, and 5 things you can do immediately that reduce your exposure risk to near zero. First, never sweep or vacuum rodent droppings dry. Dry sweeping aerosolizes the virus directly into your breathing air. Soak all droppings with a 10% bleach solution first, per CDC cleanup protocol. Second, ventilate any enclosed space suspected of rodent activity for a minimum of 30 minutes before entering. Open doors and windows and stand back. Third, wear an N95 respirator or higher during any cleanup of potentially contaminated material. A surgical